Welcome to the mathematics video class. Today we are going to learn about the rational numbers. The first type of number systems is natural numbers. So what are natural numbers? All the counting numbers are called natural numbers. They are denoted by capital N. As we all know, the smallest natural number is 1 and the largest natural number is undefined. Next comes the set of whole numbers. So, what are whole numbers? The set of natural numbers together with 0 forms the set of whole numbers. They are denoted by capital W. The smallest whole number is 0 and the largest whole number is undefined. After the set of natural numbers and whole numbers, next we have integers. What are integers? Integers are the set of positive and the negative numbers including 0. The set of integers are represented either by Z or I. Both the smallest and the largest integer are undefined. But the largest negative integer is -1, whereas the smallest positive integer is +1. Take a look at the definition of rational numbers. The numbers which are in the form of P by Q, where P and Q belongs to the set of integers and Q is not equal to 0 are called rational numbers. The set of rational numbers is denoted by capital Q. That is because rational numbers are also known to be the quotient numbers. Now do you understand, children, why 1 by 2 is called as a rational number? 1 by 2 is in the form of P by Q, where 1 and 2 both are integers and the denominator Q, that is 2, is not equal to 0. So, all the natural numbers, whole numbers and integers are rational numbers as they can be expressed in the form of P by Q. For an example, if you consider the natural number 2, the natural number 2 can be written as 2 by 1. If you consider an integer -5, the integer -5 can be written as -5 by 1. What do you mean by standard form of rational numbers? A rational number P by Q is said to be in its standard form if it is written in its simplest form, which means P and Q both have to be coprimes. Do you remember what are coprimes? Yes, which means their highest common factor is 1. Also note that the rational number P by minus Q is same as minus P by Q is same as minus P by Q. It is easy to represent integers on a number line. But in today's session, we are going to learn how to plot a rational number on a number line. Let us plot 3 by 4 and its corresponding number minus 3 by 4 on the number line. Here, the numerator is less than the denominator, which means the positive rational number should lie in between 0 and plus 1, and the negative rational number minus 3 by 4 should lie in between 0 and minus 1. Take a look on plotting 3 by 4 on the number line. We all know that 3 by 4 lies in between 0 and 1. Step 1. Divide the distance between 0 and 1 into 4 equal parts. Now, dividing the distance into equal parts depends on the denominator of the given number. In the given number 3 by 4, 4 is the denominator. So, we are dividing the given line into 4 equal parts in between 0 and plus 1. Step 2. Represent each part towards right of 0 as 1 by 4, 2 by 4, 3 by 4 and 4 by 4. 4 by 4 is nothing but equals to 1. Step 3. Round up the required number 3 by 4. That's all. So these are the steps to plot a positive rational number where the numerator is less than the denominator. So my dear Slaters, now can you tell me what are the natural numbers between 1 and 5? Yes, they are 2, 3 and 4. Next, what are the numbers between minus 2 and plus 1? You have two integers, that is minus 1 and 0. Now can you tell me few rational numbers between 1 by 2 and 3 by 4? Exactly. We cannot tell what are the rational numbers in between 1 by 2 and 3 by 4. So, now let us learn how to write the rational numbers between the two given rational numbers. So children, we have three different methods to find the rational numbers in between the two rational numbers. The first method is converting the two rational numbers into the decimal form. The second method is known to be n plus 1 method, and the third method is known to be the arithmetic mean method or simply mean method. Now, let us try to understand the first method, that is converting into decimals. Let's take an example. Find 5 rational numbers between 1 by 2 and 3 by 4. We know that 1 by 2 is equals to 0.5 and 3 by 4 is equals to 0.75. So, we can write many rational numbers between 0.5 and 0.75 like 0.51, 0.52, 0.53, so on, 0.6, 0.61, 0.62, 0.63, so on, 0.7, 0.71, 0.72 until 0.74. Like this, we can find many rational numbers between the two given rational numbers. Before you understand the method 2, that is n plus 1 method, you need to know what do you mean by n here. N represents the number of rational numbers that we have to find. Let us take an example and try to understand the method 2. Find 5 rational numbers between 1 by 2 and 3 by 2. Here, the value of n is equals to 5 because we need to find 5 rational numbers between 1 by 2 and 3 by 2. Now, if we are finding 5 rational numbers, then we need to multiply the numerator and the denominator of both the rational numbers with n plus 1. So what is n plus 1 here? N plus 1 is nothing but 5 plus 1, that is equals to 6. So take the first rational number 1 by 2 and multiply the numerator and the denominator by 6. 1 into 6 by 2 into 6 is equals to 6 by 12. Similarly, 3 by 2 should be multiplied with 6. 3 into 6 by 2 into 6 is equals to 18 by 12. Now children, can you tell me the rational numbers between 6 by 12 and 18 by 12? Yes. The rational numbers between 6 by 12 and 18 by 12 are 7 by 12, 8 by 12, 9 by 12, 10 by 12, 11 by 12, 12 by 12, 13 by 12 until 17 by 12. You can choose to write any 5 rational numbers out of these rational numbers. Like this, we can find infinite rational numbers in between the two rational numbers. Dear Slaters, kindly take a note that the example that we have considered here had two like fractions, that is 1 by 2 and 3 by 2. Now in this example, let us consider the unlike fractions. Find 5 rational numbers between 1 by 2 and 3 by 4. Here 1 by 2 and 3 by 4 have different denominators, so they are unlike fractions. Firstly, we need to make the unlike fractions as the like fractions. Children, how do you convert unlike fractions into like fractions? Yes, by writing them into equivalent fractions. That is, by taking the LCM of the denominators 2 and 4. The LCM of 2 and 4 is 4. So 1 by 2 can be written as 2 by 4, whereas 3 by 4 will remain as 3 by 4. Once we convert the unlike fractions to like fractions, we need to follow the same series of steps as we have done before. Here, we need to insert 5 rational numbers between the given rational numbers. So, the value of n is equals to 5. So now children, can you tell me the numerator and the denominator of the given rational numbers should be multiplied by which number? Yes, it should be multiplied by 6 because n plus 1 is equals to 6. So 2 by 4 into 6 by 6 is equals to 12 by 24. 3 by 4 into 6 by 6 is equals to 18 by 24. Now, the 5 rational numbers between 12 by 24 and 18 by 24 are 13 by 24, 14 by 24, 15 by 24, 16 by 24 and 17 by 24. Like this, we can find infinite rational numbers in between any two rational numbers. Now, here comes the most interesting method, that is arithmetic mean method or simply mean method. My dear Slaters, can you tell me how do you find the mean of two numbers a and b? Yes, it is nothing but the average of a and b, which can be found by a plus b by 2. Now, the same concept we will be using to find the rational numbers between the two given numbers. For an example, let us find three rational numbers between 2 and 3. The first rational number between 2 and 3 is 2 plus 3 by 2. That is the average of 2 and 3, which is equals to 5 by 2. Now, can we find the second rational number in between 2 and 5 by 2? Yes, that is 2 plus 5 by 2 divided by 2, which will result into 9 by 4. Now, let us find the third rational number between 5 by 2 and 3. That is 5 by 2 plus 3 divided by 2, which is equals to 11 by 4. So, the three rational numbers between 2 and 3 are 5 by 2, 9 by 4 and 11 by 4. Children, you all are already aware that every rational number is in the form of P by Q, where Q is not equal to 0 and P and Q are integers. Let us express rational numbers in the decimal form. Observe the table given in the next slide carefully. Here, we have considered three rational numbers, 20 by 4, 25 by 2 and 5 by 3. When we convert 20 by 4 into the decimal form, we get it as 5, which can be written as 5.0. 25 by 2 is nothing but 12.5, whereas 5 by 3 is nothing but 1.666666 and so on. Any decimal number can be categorized as follows. Either it is a terminating decimal number or a non-terminating decimal number. If it is a non-terminating decimal number, then it can either be recurring decimal or non-recurring decimal. Take a look at the examples in each case. 1.25, 3.6, 2.75, 4.8, all these comes under terminating decimals because after the decimal point we have fixed number of digits. Non-terminating recurring decimal. Example 1.333333 so on. 0.575757 so on. Here you can see that after the decimal point there are set of digits which repeats itself. Whereas the examples for non-terminating non-recurring decimal 3.1749562 so on. Here after the decimal point there is no such pattern of repetition of the digits. Children, it is very important for you to note that only a terminating decimal or a non-terminating recurring decimal can be expressed as a rational number. Expressing terminating decimals in the form of P by Q. Let us take a look at it. Example 2.5. 2.5 can be expressed as 25 by 10, whereas 1.44 can be expressed as 144 by 100. You all can see that in the above examples, after the decimal point, we have the fixed number of digits. In the first decimal, we have one digit after the point, and in the second example, we have two digits after the point. Such decimals are called the terminating decimals. Children, in non-terminating recurring decimals, After the decimal point, we do not have the fixed number of digits. For example, in case of 1.6666 and so on, after the decimal point, do we have the fixed number of digits? No. So, here it is not possible to express it in P by Q form directly. Now, let us learn how to convert the non-terminating recurring decimals into P by Q form. Also take a note that 1.6666 can be written as 1.6 bar. The digits under the bar gets repeated. Before we convert the non-terminating recurring decimals into P by Q form, let us learn about period and its periodicity. In a non-terminating recurring decimal, the set of the digits which repeats is called the period. And the number of digits in the period of the non-terminating recurring decimal is called its periodicity. Example, in the decimal number 1.66666, the period is 6 because 6 is the decimal part which is repeating, whereas the periodicity is 1 because there is only one digit which is repeating. Consider the next example, 3.575757 so on. Here, the two digits which are repeating is 57. So the period is 57. Whereas its periodicity is 2 because we have two digits which are repeating in the decimal part. Here, the given decimal number is 0.57 bar, which means 0.575757 so on. Consider x is equals to 0.57 bar, that is 0.575757. Let this be the equation 1. Step 2. Write the period and its periodicity. Here, the decimal digits which are repeating is 57. So the period is equals to 57. And since there are two digits repeating, the periodicity becomes equal to 2. Step 3. Multiply both the sides of the equation by 10 to the power periodicity. Here, 10 to the power periodicity is nothing but 10 square. 10 square is 100. So multiply the equation 1 by 100. 100 into x is equals to 100 into 0.575757 so on, which is nothing but 100x is equals to 57.5757 so on. Now this is the equation 2. Step 5. Subtract the equation 1 from the equation 2. 100x is equals to 57.5757 so on, and x is equals to 0.5757 so on. When we subtract these two equations, we get 99x is equals to 57. Step 6. Solve for the value of x. If 99x is equals to 57, then x is equals to 57 by 99. This can be simplified as 19 by 33. Hence, 0.57 bar is equals to 19 by 33 in the form of P by Q, where P is 19 and Q is 33.